This is R.D. Sharma Solution Class 12, Chapter 6, Determinants. Exercise is 6.2. Now, these kind of question, you can have x, you can have lambda, all these, there are multiple questions we have seen like this. The best thing is to do what? Just add the row 1, row 2, row 3. So, we are changing row 1 to row 1 plus row 2 plus row 3. So, whatever we come, we arrive, that is 1 plus a plus 1 plus 1 is 3 plus a. Same for the other 3 columns. So, 3 plus a will come common in the first row for all the other additions, right? 3 plus a, 3 plus a, 3 plus a. So, when we add the 3 rows, we get 3 plus a. What is remaining? 1, 1 plus a, 1, 1, 1 and 1 plus a. Now, just take 3 plus a common from all of it. When you take 3 plus a common, 1, 1, 1, 1, 1 plus a, 1, 3, 1, 1, 1 plus a will remain. Now, just get as many as zeros you want, so that the calculation becomes easy, computation becomes easy. So, you can either subtract the rows, you can either subtract the columns, which way you like. I am not bounding it. So, there may be multiple process, okay. So, let us say that C1, C2, C3 are the columns. So, we will change column 2 to column 2 minus column 1 and column 3 to column 3 minus column 1. So, column 2 minus column 1, 1 minus 1, 0, 1 plus a minus 1 is a, this is a, 1 minus 1 is again you get 0. Now, similarly C3 to, we change C3 to C3 minus C1. 1 minus 1 0, 1 minus 1 0 and 1 plus a minus 1 is a. Okay. So, 3 plus a is already outside, remember, it is already there. Now, we are opening it. 1, you get a, 0, 0, a. Minus 0 and plus 0, so I am not dealing with that. So, what do you get? A square here, a square minus 0 is a square only. So, multiplication is a square into 3 plus a. What do you get? 3a square plus a cube, and that is what we wanted. Next one here. Now, we'll do it properly step by step. But what do we need? X plus y plus z and x minus z whole square. So, the best thing is, this is row 1, this is row 2, this is row 3. So, if we add row 1 with row 2 and row 3, we get x plus y plus z in the second and third column, top of the column, and twice of x plus y plus z on the first member. So, R1 plus R2, R3 we are doing. So, it will be 2x plus y plus z, x plus y plus z here, x plus y plus z here, and then we have z plus x, z, x, x plus y, y, z. Now, we take x plus y plus z common from here. X plus y plus z, when we take common, what will be inside? It will be 2, 1, 1, z plus x and zx, x plus y, y and z. Okay. Now, we will try to get maximum zeros, basically maximum zeros means less computation. You can do twice of this minus, or you can add the column 2 and column 3 and then subtract it with column first. You will get the zeros, 2 zeros here. Okay. So, we are changing, or you can just do column 2 minus column twice of column 2 minus column 1, that also you can do. Twice of column 3 minus column 1, that also you can do. Because essentially the idea is to get maximum zeros in the determinant, in the process of determinant, in this matrix basically. So, let us do it. We do like this. C1 we are changing to C1, we are taking C1 minus this column 2 plus column 3, that is C1 minus C2 minus C3. You can also write it as C1 minus C2 plus C3. This is also the way of writing. So, x plus y plus z is already outside, remember. Now, 2 minus 1 is 0, z plus x minus z minus x is 0, x plus y minus z, so you get x minus z here. And what is remaining? 1, 1, z, x, y, z. Now I think we need to open it using the first column. So 0 into something minus 0 into something plus x minus z. So what do you get here? 1z and 1x. So x minus z into x minus z. Since we have 2x minus z, you can write it as x minus z whole square. And as we have already x plus y plus z outside, so x plus y plus z into x minus z whole square is your final solution. Now without expanding, so we will just exchange the rows and column. This is very easy, let me tell you, just take the rows and columns, exchange it, or you can take the transpose also. So let me show you the first one. So we are exchanging row 2 and row 3. Whenever we exchange the row and column, one means one pair of row and column, it will be negative. The result will be negative. So we are changing the row 1 and row 2 and row 3. Okay, this is the first we did the row change, and again we change the rows. Row 2, row 3, and then row 1, row 2. So we got the final answer. What about this one? See, if we take the transpose also, the determinant won't change. So this y, x, z and b, a, c, q, p, r, the first column has to be made in row, second column to row, and third column to row. So now this A transpose, we got this matrix, but still we need to change the columns. So we are changing the column 1 and column 2, exchanging. So it will be negative. So you get x, y, z, a, b, c and p, q, r. But still we need something, because a, b, c is in the last row and p, q, r is in the second row. So we change the row 1 and row 2, or row 2 or row 3, whichever way you want. The main crux is that if you exchange the row you can change ri to rj. You can exchange the column I to column j, or even you can take the transpose. The things remain same, only the row change will have a negative sign. Oh, A, B, C are in AP. See, this question and next question are exactly same. Almost same means 2B equals A plus C. When you have basically B minus A equals C minus A, then only we say that they are in AP, arithmetic progression. So 2B equals A plus C. So the main key behind solving this kind of questions is simply, there are two tricks. First, you have to multiply the middle row by 2. First thing, you will just know why we are doing it. So we will multiply the middle row with 2. X plus 1, x plus 2, x plus a is there. Now I am multiplying row 2 to twice, but since we are multiplying with 2, you have to have a half also outside, because you cannot just introduce any number. You have to have a cancellation also. So multiplying 2x plus 4, 2x plus 6 and 2x plus b. Then this remains the same, x plus 3, x plus 4 and x plus 6. Okay. Now why did we do this? First of all, this 2x plus 2b. 2b can be written as a plus c. In place of 2b, you can write it as 2x plus a plus c. Now just cancel it. If we take 2x plus a plus c, and if we subtract the first row number and third row number, so 2x plus a plus c minus x minus a minus x minus c, you get 2x gets cancelled, a get cancelled, c get cancelled. You get a 0 here. So row 2 we are changing to row 2 minus row 1 plus row 3, or you can always say that row 2 minus row 1 minus row 3. These two are same. This is what we are doing right now. Okay. So 2x plus 4 minus x minus 1 minus x minus 3 is 0. 2x plus 6 minus x minus 2 minus x minus 4 is again 0. And 2x plus a plus c minus x minus a minus x minus c is also 0. So ultimately the middle row, that is row 2, is 0. So any of the column or row is 0, determinant will always be 0. So as I just indicated, this is also the same question, almost. How it will be? First step is what? Because we have alpha, beta, gamma in AP, arithmetic progression. So twice of beta is alpha plus gamma. So we are multiplying the middle one by 2. So you have to have a half outside. So 2x minus 4, 2x minus 6, 2x minus 2 beta. Here you have x minus 1, x minus 2 and x minus gamma. So alpha, beta, gamma, since they are in AP, twice beta is equal to alpha plus gamma, right? So we will replace this 2 beta with alpha plus gamma. So 2x minus alpha minus gamma, right? It is gamma, not alpha, right? So 2x minus alpha minus gamma. So we will change R2 to R2 minus R1 minus R3. So 2x minus alpha minus gamma minus x plus alpha minus x plus gamma. What are you going to get? We are going to get 0. Same as the previous question. So rho 2 we are changing to rho 2 minus rho 1 minus rho 3. Or you can also write like this, rho 2 minus rho 1 plus rho 3. So 2x minus 4 minus x plus 3 minus x plus 4 is 0. 2x minus 6 minus x plus 4 minus x plus 2 is 0. And this one I already showed you, it is 0. So the middle row, that is the row 2, is becoming 0. So when you have a 0, a column or a row as 0, that means the determinant is going to be 0. Now this question we have already seen. These questions are likewise. You just have to apply one common thing in all of these. Row 1 should be changed to rho 1 plus rho 2 plus rho 3. Just add all the rows. So the first row will have all the values which are similar. X plus 1 is 2. Here also x plus 2. Here also x plus 2. Right? Now when we take x plus 2 outside, what will remain? 1, 1, 1. So this 1x, 1, 1, 1x is there. So x plus 2 I am taking outside. You get 1, 1, 1 here. You get 1x, 1 and 1, 1x. Now since first row and second row, if you subtract, you will get 2 zeros. First column, second row, second column, if you subtract, you will get 2 zeros. So either way you can do. So we are doing column 2 to column 2 minus column 1, 1 minus 1, 0, x minus 1, 0. Column 3 we are changing to column 3 minus column 1. So column 2 we already did. Column 2 was column 2 minus column 1. So 1 minus 1 is 0. 1 minus x it will be, no 1 minus 0. X minus 1. So 1, 1, 1. Column 3 minus column 1. Column 2 minus column 1. So 1 into something we are opening using the first row, minus 0 into something plus 0 into something. So we are just taking the first one. So x minus 1, 0, 0, x minus 1. Now when we multiply, x minus 1 whole square. X minus 1 whole square minus 0. 1 into x minus 1 whole square is x minus 1 whole square. So you get x minus 1 whole square into x plus 2. This is the final answer. So how to do this? These are the stepwise ways which you can do it. Now if A, B, C are real numbers such that this equals 0, so determinant is 0. This is 0 only when A plus B plus C is equal to 0 or A equals B equals C. So the first thing first is row 1, row 2, row 3 if you add, what do you get? These are columns, these are rows. So row 1, row 2, row 3 just add it. I'll show you one of these. For B plus C, C plus A and A plus B. What do you get? 2A, 2B, 2C. 2A plus B plus C actually. So this in all the three. So 2A plus B plus C. This I am taking common because as I said, the first row will contain only this. So 1, 1, 1, 1, C plus A plus B, B plus C, B plus C, C plus A. So we have done row 1 changed to row 1 plus row 2 plus row 3. Twice A plus B plus C we have taken common. Now to make it simple, whenever this comes, the best way is to column 2 just change to column 2 minus column 1, column 3 change to column 3 minus column 1. This is the best way to do it. So this column 2, 1 minus 1, 0, A plus B minus C minus A. So this A gets cancelled, you get B minus C here. B plus C minus A minus B, B plus C minus A minus B. So BB gets cancelled, you get C minus A here. Now coming to this one. 1 minus 1 is 0, b plus c minus c minus a, b plus c minus c minus a. So c gets cancelled, you get b minus a. C plus a minus b. So c gets cancelled, you get a minus b. So you get c minus b, you get c minus b. The first column was already there, 1 c plus a plus b. Now let us open using the first row. So first row, 1 into b minus c, b minus a, c minus a, and c minus b. Rest will be 0, 0, so I am not taking it. So now let us, as I am saying, minus 0 something plus 0 something, I am not taking it. Now b minus c into c minus b minus c minus a into b minus a, this will come. Now this b minus c, c minus b, so you can take negative common. You can take because we want to make it as b minus c whole square. So you have to take a negative common from one of it. So let us say we are taking minus b minus c, minus is outside, b minus c whole square. What is this c minus a, b minus a? Now since we have two negative, let us take this negative outside. So I am taking this negative outside, so it will be negative outside. This is negative. Okay. Now b minus c whole square will be b square plus c square minus 2bc. Oh, we can do one more thing. Minus 2bc, let us do this first, and then plus cb minus ac minus ab plus a square. So let me write it like this. We have 2 outside, so let us multiply 2 inside. So b square plus c square minus 2bc plus cb is minus bc. And then we have minus a square, I am writing it here. And cb minus 2bc is minus bc minus ab minus ab. So let us multiply this whole by 2. So I am taking 2 from outside. So 2a square plus 2b square plus 2c square minus 2bc minus 2ac minus 2ab. So we will multiply 2. So what do we get? See, a square plus a square, 2b square is b square plus b square, 2c square is c square plus c square minus 2bc minus 2ac minus 2ab. Now you see the formula. A square plus b square minus 2ab is a minus b whole square. Now a square plus c square minus 2ac is c minus a whole square or a minus c whole square. A minus c whole square, c minus a whole square. Now b square plus c square minus 2bc is b minus c whole square. So what do you get? You get a negative a plus b plus c into this term as the final determinant. So a plus b plus c into, minus was already outside, a minus b whole square plus b minus a minus c whole square plus b minus c whole square. This is going to be 0. When it will be 0? See, if you say x dot y is 0, that is x may be 0 or y may be 0. So a plus b plus c is 0 either, or because these terms are in plus, so individual terms has to be 0. So a minus b has to be 0, a minus c has to be 0, and b minus c has to be 0. That means a should be equal to b, b should be equal to c, and c should be equal to a. That means a equals b equals c. This is the second condition. Okay. Now show that x equals 2 is a root of this equation and solve it completely. X equals 2 is root of the equation, that means x minus 2 is a factor of this particular matrix whose determinant is actually 0. Okay. So how do we do this? First, let us try to find out such that we get something out of it. X plus 3 I am going to take out. How? Now you see, row 3 will change row 3 minus row 1. Just see, row 3, if we take minus 3, row 3, minus 3 minus x, 2x minus 1 minus x, that is 2x plus 6, and x plus 2 minus 1 minus 1, x plus 3. So every time we are getting x plus 3. So x minus 6 minus 1, 2 minus 3x, x minus 3, minus 3, and 2x and x plus 2. So minus 3 minus x is minus 3 minus x, 2x minus 6 is 2x plus 6, I'll just change it, x plus 2 minus or minus 1 is x plus 3. So I'll just change it. So it will be 2x plus 6 and x plus 3 and 2x plus 6. So x plus 2 minus or minus 1 is x plus 3, 2x plus 6 and minus 3 minus x. Minus 3 minus x. Now from the third row, we can take this 3 plus x, minus 3 plus x. You can take 2 common from here. You will get x plus, if you take x common, you get 2x plus 3 inside. And third one is already x plus 3. I am talking about the third row. So in the third row, you can take x plus 3 common. So 3 plus x or x plus 3, whichever you can take common. X minus 6 minus 1, 2 minus 3x, x minus 3, minus 1, here minus 1, here 2, or 1 will remain. This is being done. How about x minus 2? Now if you take row 1 and row 2, if you subtract, you will get x minus 2 and minus 6 minus of minus 3x, that is minus 6 plus 3x, that will also give you x minus 2, and minus 1 minus of x plus 3, that will also give you x minus 2. That is, since we know already that x equals 2, x minus 2 is already a factor. So we are actually witnessing that x minus 2 we are getting if we do R1 minus R2. So I am just trying it. X minus 2, you also get 3 here also. So row 1, row 2, row 3. So row 1 I am changing to row 3, row 1 to row 1 minus row 2. So x minus 2 here, and then we have this minus 6 minus of minus 3x. So minus 6 plus 3x it will be. And then we have minus 1 minus x plus 3. So what do you get? Every time you get something so that x minus 2 can be taken out. Okay, now I am taking the x minus 2 from the first row. So 3 plus x was already there. X minus 2 we are taking now. What is remaining? X minus 2. This you can write it as 3x minus 2. So 3, and here you take minus 1. So minus 1 minus x plus 2 it is. So minus 1 it will be. So 2 minus 3x, x minus 3, 1 minus 1, 2, 1. So can we do something more so that we get some zeros here? So let us try. See, first row and third row we add, and we just add first and third row. 0, 5, 0 will come. 2 minus 3x, x minus 3, and it will be minus 1, 2, 2, 1. So we have just added row 1 and row 3, and we got this. Now let us open it. 0 into something, minus 5 into, let us write something here. So what do we get? Minus 5. So 2 minus 1, x minus 3, 1 will come. Minus 5. And then plus 0 something, so I am not writing it. So it will be 2, negative 1, and x minus 3 and 1. So now do it. 2 into 1 is 2, minus become plus, x minus 3, and this will become, so this will become x minus 1. Minus 5 is outside. So we have minus 5 into x minus 1. What was outside? So minus 5 into x minus 1, 3 plus 5, x and x minus 2. These are all the factors. So x equals 2, x equals minus 3, and x equals 1 is the answer. Okay, this we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.